So, as promised from last week, here we present a chat with Javier from Libellium again, but this time we'll be discussing everything you'll ever want to think about when designing an IoT system, or as Javier puts it, a good IoT system. I'll apologize in advance that I was very, very hay fevery throughout this interview, so I'm quite silent and struggling to breathe for a lot of it. But it gets really interesting, so stick around. So, hi everyone at ipXchange. We're here with Javier from Libellium. We talked to him about Wasp Moat last week, and as I said in that post, we would do a little follow-up about designing an IoT device. So, without further ado, Javier, very good to meet you, and yeah, let's find out.
Hi, Eamon. It's nice to be here. So, well, I have prepared a short presentation.
Cool.
Just to show you my opinion about how to choose a good IoT platform. So,
Cool.
if you want, I can share my screen. Give me a sec.
Cool, and I'll ask you little questions along the way if we need.
Yeah, sure.
Cool.
Just ask me whenever you want. So I think you are seeing my screen now. Here we are. I'm going to put it in presentation mode. All right. So the topic today is how to choose a good IoT platform. Okay. So let's see how to do it. Well, here we have the main aspects to consider when you have to choose your new IoT platform. This is a very short presentation, only 7 pages long. So here we have the 5 main aspects: hardware, software, intangibles, processes, and price. This is a kind of standard process that I have designed throughout the years. This process helps me to analyze new companies from the competition or new partners in a rational way and in a standard way.
Cool.
So afterwards, we are going to zoom in each one of these categories. And I should say that, of course, everything depends. There are not absolute answers. So depending on your case, on your application, you should give priority to some points or to others. Okay?
Right. And I guess we'll find out what Intangibles is in a minute.
Yeah, it's an obscure concept.
Yeah. Cool.
Let's check that. Well, the very first aspect is hardware, the device, the IoT node. It's probably the most obvious aspect that we should evaluate with an IoT platform. And of course, hardware is really important because that's the basis of everything. But as we will see, it's not the only point to evaluate. Okay, so the first point is sensors inside hardware. Probably that's the most important point when evaluating an IoT platform, because IoT is all about sensing the world, right? So you want to see the total number of available parameters in the platform. That means the native sensors that they have already integrated, the number of sensors at the same time that you can have on your node, the data quality related to precision, accuracy, the range, calibration needs, durability, lifetime, and the ability to integrate new sensors. Okay. Next subcategory is communications or radios. The amount of available technologies or radios that you can choose, the range, distance, the throughput or bandwidth. You should check also if the radios are bidirectional, how easy it is to transmit to the internet with them, if they use standard protocols, how much power consumption they have, and the existence of a public infrastructure or the need of a private network. Also, you have control, you should check the microcontroller performance or speed, how many ports it has, the buses, the memory availability, and if they use an operating system, a real-time operating system with multi-thread, etc. Then we have power. You should evaluate the power consumption. If the node has power-saving modes like sleep, hibernate, the battery size and type, battery life with the total consumption, and the recharging options, for example, with a solar panel, etc.
Cool.
Also, we should see into the housing or the enclosure, the robustness of the main box, if the IP grade it has for the rain and dust, the IK grade for the
What's the IK grade?
IK is related to mechanical protection.
Oh,
IK
okay.
goes from 1 to 10, and the maximum IK is 10, and that means that the enclosure can stand a ball of 1 kilogram falling from 1 meter high.
Oh, okay.
I think
Cool.
something like this. Okay, so
Yeah.
the total robustness of your box. You should look into the physical interfaces, the buttons, connectors, potential signaling, the size, weight, and the design or aesthetics. And finally, you should check the physical accessories, if any, for your installation in the real world.
What kind of things will be under physical accessories?
The physical accessories, I mean, you could have special brackets for installing your node on a lamppost, a tree, on a building. You know, normally there is a variety of installation accessories.
Cool. Just because I didn't ask with IP because I know IP grades from some previous work, but can you just explain IP grades for our audience as well?
Sure. Well, IP has always two numbers. For example, it's very, very common to have IP 65, 6, and 5. The first digit explains how tight is the enclosure for dust entrance, okay, for physical dust entering the node. It goes from 1 to 6, and that means that 1, you can put your finger inside the enclosure, so it's not really protective, and 6 is the maximum, and that means that it will avoid any dust entrance.
Cool.
And the second digit is related to the water protection.
Oh, okay.
It goes also from 1 to 8, I think, and 5. In that case, this is really common, 65. 5 means that the enclosure is protected against water jets from any direction. I think something like this. Okay. And 66 or 67. That means that the enclosure can be under the water.
Okay, yeah, that sounds familiar. Cool.
Okay. So hardware, the very first thing. After that, we have software. IoT, I think, is much more than hardware. So we have software. So it's key how you make use of your data that you got from your nodes, from your hardware. In my opinion, the final customer, the final user, doesn't really want data, but information that you get from data. That means insights.
Okay. Yeah.
I believe that IoT is evolving from being hardware-centric to being software-centric. So there is a lot of money in the software applications, AI, insights creation, predictions, So the very first thing you should study in software is how you are going to program the firmware of the device. If there is a good SDK or IDE, if the company has created high-level libraries in the API to ease your development, if there is good documentation, good code examples, if there are no-code tools, and how the upload is done. For example, you should have options for on-site upload and also remote upload of firmware, which is commonly known as OTA, over the air.
Yeah.
Next category is really, really important, probably is the most important point in the presentation. It's the software services on the platform. Of course, you want to choose a platform that is not only hardware, but also software. You want to have a platform managing the licenses, nodes, users, roles, grouping, all the data ingestion, database, also showing data with logs, filtering that, plotting graphs, maps, also creating reports in a periodical way, having some capability for setting thresholds to trigger alarms or alerts. You also want to be able to export data or to forward data to other cloud services or servers. You should have an API, and then you want to have your data processed with statistics, any kind of analytics, AI, machine learning, business intelligence, everything related to the creation of insights, suggestions, prescriptions, digital twin, edge computing, etc. This is an almost infinite world, and I believe that most of the value for the final customer is created inside the platform.
Okay, so I guess the platform is almost kind of the central hub for your whole IoT network, is it?
Yeah, that's correct.
Okay.
Many companies, they have their own platform. For example, in Libelium, we do have our platform with most of these features always running. And some other companies, they rely on external platforms, for example, in AWS or Azure.
Oh, yeah, okay. Just out of curiosity, what kind of things would be business insights? BI?
Yeah, business intelligence, I mean.
Oh, business intelligence.
It's related to AI, I mean, creation of insights, creation of pieces of intelligence or pieces of useful information from the point of view of a business,
Oh, okay.
mainly to reduce costs and to rise yield or to rise productivity.
Do you have an example of what one of those would be?
Yes, of course. For example, BI is normally applied to smart manufacturing, like Industry 4.0, and this that means that the manager of a factory, he wants to have the maximum productivity. For example, he wants to have the machines always running with no downtime, and he wants to have the perfect quality in the output of the pieces that are created. So a lot of software platforms, they create reports for business intelligence to check how efficient you are running your factory.
Okay, cool.
And this, of course, can be translated to any field of the IoT, like agriculture or smart water or smart cities.
Cool.
That's the point. Okay, so I continue with the interoperability. Of course,
Yep.
you want to have the ability to connect with other entities, other sensors, cloud platforms, technology, protocols. So it's really important to be interoperable. Many reports about IoT, they say that the lack of interoperability is affecting the IoT, the expansion of the IoT. Okay,
So
we should use
is that operations between stuff on different IoT networks?
That's correct. Yes.
Okay.
That means, for example, using standard protocols like MQTT or HTTP, just to be able to connect to any other platform or devices.
Okay. Cool.
Then we go with cybersecurity. Sure, you want to have your node and your cloud platform perfectly secure. And last, the special functionalities. The software world is almost infinite, so you have dozens or hundreds of companies offering a lot of services related to software and data processing.
Will that be application-specific things?
Yeah, mainly
Okay.
applications for your specific use case.
Cool.
All right. So
On to
next, sorry.
processes. Cool.
Yeah. Next point is processes. You should study how the processes are. Here we have the different phases of your project in a chronological order. So you want to study how the company presents the solution, how efficient the sale process is, how well they manufacture or assembly the product. You want to see if they have an efficient, a good quality control process to deliver the best products without any fails.
This is from the this is from the perspective of a design engineer looking into someone who provides IoT components, is it?
Absolutely, yeah.
Okay.
Yeah. As a design engineer, you want to select a proper platform that when you run into production, you will receive perfectly functional boards. So it's really important to check that the company performs a good quality control.
Oh, good.
Then we arrive to a very important point. This is at customer. You want to make sure that the software and hardware handling is easy, is efficient. You want to make sure that the company created good documentation, good software tools, good code examples. So it's really easy to you to use their platform. Okay. Then we have provisioning. That means that the software and hardware activation is easy, is straightforward. Then you want to install the devices on the street, on the field. So make sure that the installation is correctly done. You have all the accessories. You have a very robust enclosure to place. And finally, you should make sure that the after sales technical support is nice to help you with any issue or any question. Sounds
Cool.
good?
Yes. Can you just expand on provisioning?
Yeah, the provisioning is the process to get your device up and running. I mean,
Okay.
When you have your device on the table, you want to start it, to register the device on the IoT platform. So ideally, you should have bulk tools to start all the devices at the same time.
Cool.
Yeah.
Cool. Yeah, that makes more sense. So that's kind of
Absolutely.
making sure the hardware gets into the IoT itself.
That's correct. Okay. Yes, because if the provisioning is needed to be one by one, it's really slow. So
yeah, and not necessarily scalable.
Mm-hmm. So that's just one aspect to look into.
Yeah. Okay.
All right. So next category is intangibles. What are intangibles? Where actually these are things that I didn't know how to put it into hardware or software. They are not hardware, not software. So you cannot touch the intangibles, but they are really important.
Yeah.
For the final quality of the IoT platform. So here we have the first thing, robustness, reliability, or maturity. the hardware and software. You want to make sure that the hardware software has no defects. There are not non-conformities. The lifetime is really long. The maintenance required is low or zero, and there are not software crashes, malfunctions, etc. Okay. And in my opinion, this is something that you get in a company with trial and error. I mean, the very first version of your platform will probably be faulty, and over time you will fix all the bugs, and you will become your platform will become a really reliable one. Okay.
Good.
Next, you want your platform to be flexible, versatile, and modular. I think that that makes sense. You want to be flexible to adapt your node to any IoT project, no matter it's about industry or agriculture or smart cities. And also you want to be modular in the sense that if you want to have a 4G radio, it's really easy to change the radio with a LoRa one, etc. Okay. And the last thing, intangible, it's related to hardware, but it's certifications. You want to be able to sell your product all around the world. So you should get the CE, FCC, UK CA for the British Islands, etc.
Yes, and I guess the modularity helps with the good modularity helps with certifications because you can swap out the different radios for the different regions.
Yeah, it's
Okay.
very related to that.
Cool.
Absolutely. And the last category is price. You want to have affordable prices, both in CapEx and in OpEx. CapEx means the very first purchase that you do with the hardware and devices. And the OpEx are the recurring costs, for example, your subscriptions. Mm-hmm. So you should study prices for the hardware, the core device, everything, the sensors, potential replacements, accessories, and then the connectivity, software platform, services, and support.
Cool, okay. Excellent. And what would you say in terms of when you're building a IoT product, where would you say you should probably allocate the most of your budget to?
How to manage your budget with an IoT project? Well, that's complicated. But recently, I read an article by IoT Analytics. I think they are really good. They said that probably 40% currently 40% of the cost of any IoT project goes to the hardware. Okay. Then 20 or 30% goes to the software, anything related to cloud, security, insights creations, and probably 20% goes to professional services, system integrations. Okay. This is more or less the distribution of costs currently. And experts say that probably we are going to see in the coming years that the hardware is lower in percentage. Okay, it goes from 40% to 30% probably, and the software increases the weight on the final budget.
Mm-hmm. Cool, interesting. In terms of connectivity, because you've got obviously there's a lot of different connectivity services in terms of networks and stuff. Which could you recommend for our audience? Which ones are networks that you'd have to pay a license, and which ones are you're a bit more free to do what you want? Because obviously, if you want to go into cellular, you're going to have to pay SIM for licensing fees. Yeah.
Well, connectivity, we have a lot of options in connectivity. You know, probably the main ones currently are LoRaWAN, 4G, and Wi-Fi. Inside 4G, I include narrowband IoT and LTE-M, okay, which are the light versions, the light flavors. So probably LoRaWAN, cellular, and Wi-Fi are the main ones currently. Basically, if you want to have your own network, you should think about LoRaWAN or Wi-Fi or other P2P protocols. And if you want to use an already existing network, you should go with cellular.
Okay.
Also, we have LoRaWAN. In LoRaWAN, you have coverage in certain countries, but it's not really broad. So in LoRaWAN, you could have both options. And I think that with 5G, they are promoting having your own network, like purchasing your own base station for.
Oh, okay.
So it's complicated because you should think about the recurring costs because okay, if some customers come to Liveli and saying, okay, I don't want to have recurring costs, and then they choose LoRaWAN, but okay, you don't have to pay a SIM card in LoRaWAN, but of course, if you install your own base stations, you will have to maintain them.
Yes.
And you
I
will
guess,
have to
yeah,
pay
that's a hidden
electricity,
cost.
and you have to connect the base stations to the internet. That means Ethernet or a SIM. So recurring costs are always present.
Interesting. Yeah. Yeah, I don't want to. I wouldn't have thought of that. So in terms of IoT for the LoRa one, forgive me not knowing, is there any place in the world at the moment that LoRa one doesn't? There isn't the infrastructure there, or because you can build a base station, can you effectively use it everywhere at the moment?
Sure. I think the best example for global connectivity in LoRaWAN is France. I mean, in France, we have Orange.
Okay.
They have a very populated network of base stations all across France. I think this is probably the country with the best LoRaWAN connectivity.
Oh,
And
cool.
and after that, we have other countries. For example, in Spain, we have a company offering LoRaWAN coverage mainly in cities. They cover main cities. The problem is that the network is not really broad. So if you go to the field for agriculture applications, for example, or environmental, probably you won't have coverage. But it's a matter of talking to them, and they may put a base station to you for your specific project. Okay. And afterwards, we have a really interesting project which is called the Things Network. I don't know if you know that, or Helium. They they have been famous lately. Well, I really like the Things Network project because it's a collaborative economy. So you put a base station, a gateway on your home, and then you can leverage other base stations all around the world.
Oh, cool. Nice.
That's pretty nice. The problem is that you rely on individuals, not in a company offering a service a high service level agreement.
Yeah, I guess you have to know where you are with that network in order to know whether it'll be effective.
Mm-hmm. So with LoRaWAN, most of our customers, they choose the option of installing their own network.
Okay.
That means buying base stations or gateways. They are around 500 euros or 1,000 euros, and you have to install that in your city, in the field, and choose a good network server like Loriot or Actility or Amazon.
Okay.
That's the point. If you want to have your own infrastructure, The other option is selecting cellular. I really like that because you pay around €1 to Vodafone, to Deutsche Telekom, Telefonica, and then they manage everything. So
Yeah.
that's
Okay.
that's magic to me.
Yeah. So I picked up on you saying that there's very good LoRaWAN connectivity within cities. When it comes to, say, agricultural IoT, unless if you don't have your own base station, would you recommend cellular for those applications, or would you still recommend LoRa?
Depends. I think it depends. You should study the specific application, the site where you are going to install that. Of course, if it's the open field, a rural area, the coverage of LoRaWAN is not really probable. Okay,
Yeah.
at least currently, at least in Spain, most of the countries. And regarding the coverage of cellular, it's unclear. Probably you will have cellular coverage, but you have a coverage of around 95% of the territory. So
Okay.
if there is
Yeah,
a very
it's very
remote
good.
area, you won't have cellular. So if you don't have cellular, of course you cannot hire the services of a mobile network operator, and you can consider the option of installing your own network with LoRaWAN, for example. But of course, remember that the base station of LoRaWAN, it needs an exit to the internet.
Yeah.
So that's the same situation. I mean, you need to send the frames of LoRaWAN to the internet, so you should have internet access for the gateways,
Okay.
and it can be complicated. I mean, the ultimate solution is satellite, because
Okay.
you have satellite coverage all around the world. But it's expensive. Probably the fees are pretty high, and the amount of data you can send is really limited. So there are pros and cons always.
Cool. Well, I think we've gone through quite a lot of what you'd want to consider in IoT design. Is there anything else you wanted to talk about? Because there's obviously last time we talked about, well, you and Guy talked about WASP mode, but you also said there's ready-made solutions that Libelium make. Did you want to talk about those at all?
Sure. Well, the basis of Libelium is WASP mode. This is our core platform. It was created like 12 or 13 years ago, so it's very mature. And as we grew, as we talked to customers, we realized that they needed higher value products or solutions. So that's why we created Plug and Sense. This is our platform, ready for the market, certified with an enclosure, and it's ready for the real world. Actually, inside a Plug and Sense, there is a WASP mode. So it's not rocket science. I mean, we just took WASP mode, we placed that inside a proper enclosure, IP65, IKEY certified, of course, and then we certified the whole end product.
Okay.
So for Europe, for America, etc. And this is probably our main product currently, Plug and Sense. After that, we have evolved the platform, and we have created one, ONE, one. And this is the evolution of Plug and Sense. This is our best product currently, and we are migrating all our customers from Plug and Sense, which was really good, but we are migrating them to one, which is the final solution by Libelium.
Cool. What's the difference between when you go up to one? What do you gain?
Well, actually, it's called one because you only need one device for any application. I should say that with Plug and Sense, we have different models. For example, we have agriculture, we have smart water,
Yes. Yeah.
gases. So it was a problem that our customers, they cannot mix verticals inside the same device. For example, you with Plug and Sense, you cannot have an agriculture sensor with a gas sensor. Okay, but in the case of one, you have only one device. There is only one SKU. You mean that means that you can mix different sensors without any problem. We have managed to get that with advanced mechanisms that talk to the sensor, and then they download the codec to talk to the sensor. Okay, and also one is really nice because it's Pseudocode in the sense that you don't need to program the platform. You just use our programmer. This is a web application. This is a web form. You just select what options you want to have with your one, which behavior you want to have. It's just a matter of a couple of minutes. You press one button, and the final firmware, the binary, is sent to the device via cellular.
Excellent.
We also offer a SIM card with global connectivity, so the customer doesn't need to deal with mobile operators. And finally, really important, we have created our software platform on the cloud for one, and it has a lot of features like storing all your data and creating insights for the final customer.
Is that insights with the kind of AI, ML, and BI functions that you were talking about earlier?
Absolutely.
Cool.
Nice. We leverage on AI. Everything is related to AI now, so we make use of all the tools that the market offers.
Excellent. Cool. And that's available now, I guess.
Yeah. It was one was released 1 year ago.
Okay.
And it's available for all customers.
Cool. And where have you seen, in terms of application and around the globe, one being used so far?
Our main applications for our products are smart cities, smart agriculture, smart water, industry also. Probably these are the main applications. Also, we have other products, other solutions for air quality measurement, environmental, and smart parking. These are
I saw the smart parking one.
Yeah, this is a kind of dish for checking if there is a car or not.
Cool. Well, it's that's been a very fun chat. Obviously, we've got the other interview as well with Guy about Waspmo, if people want to check that out. But I'd like to say a big thank you to Javier for having me, especially if anyone has noticed I've got hay fever.
Okay, so, thank you very much. It was really interesting. I hope you liked the conversation.
Yeah, really enjoyed it. Thank you. So I'm sure I'm not the only one who learned a lot in that long conversation with Javier. Obviously, if you want to try out Libellium's technology, we've got the Waspmo platform on our website, so you can have a look at that and apply to evaluate the technology. But also use the same form if you want to look into evaluating one, which really looks like the complete solution all done for you.